Hey everyone, in this video I'm going to show you how to use Proteus Measurement and how to set up a new experiment. So this is the main menu of Proteus Measurement that you will see when you initially launch it. Along the top you can see your file options. You'll have a toolbar below that with some commonly selected functions, and then you'll have your main graph view, which currently will be showing the idle statistics of the instrument, but will also show you the live data during your experiment once you start running it. A couple commonly used toolbar options is the View Signals button, which we'll use to view the current operating conditions of the instrument, including the temperature, DSC signals, TG signals, and all of your gas flows. You'll also commonly use the Furnace Temperature button, which will show you the current temperature of the furnace of the instrument, which you'll note is distinct from the sample temperature, which is shown in the Signals box. You may also want to open the Mass Flow Gases Extended dialog, which allows you to control the current purge gases going into the instrument. To start a new measurement, you can either create a new file or open a previous file. If you were to open a previous file, you would simply select an old measurement, and then you would be able to click Get These Properties from Just Open Measurement, and it would fill in most of your existing data. However, in this video, I will show you doing it from scratch, as that's the most universally applicable method. So, to create a new measurement, you can click on File New to create a new measurement definition, and then you'll be prompted with this measurement definition dialog box, which I'll take you through now. This is a pretty linear process in which you'll go across the tabs at the top until you get to the last items, in which case you'll start the measurement. So the first tab is Setup. Most of this will be pre-filled for you. This will just define the actual instrument, the furnace, and the sample carrier that you're using. One thing that you may want to change is the crucible type if you were using something other than the platinum rhodium 20% 85 microliter with lid. One other common one would be an alumina crucible, 85 microliter, either open or with a lid. The measurement mode you'll generally always leave to DSC and TG. You can just leave it at TG, but there's really no benefit to doing so. It'll just throw out the DSC data that's collected anyway. Start criteria will allow you to select some conditions that are established before the beginning of the test. So you can do stuff like making sure that the TG signal is stable, the temperature is stable, or setting the time in which those two rates have to be stable before starting the test. None of the other settings you will commonly use and generally should not be touched. The next tab will define the header of the test, which is the measurement type and then all of the metadata and information about your sample. So you can either choose a correction or a sample file. A correction will be run before or after your main sample file. In this case, I will select sample to just show you more of the options. You can fill in the laboratory in which the sample was tested, the project, which you may want to assign it to, the operator, which will be your name, and the material, which will be the material that you're actually testing. In the sample field, you'll fill out the name of your sample. In this case, I could just call it red oak. You can also input the mass of your sample, so this will be what you measure from the external balance. It could be, for instance, something like 4.00 milligrams. The crucible mass would be the mass of the empty crucible. It's not necessary to input this data because it's not used for any calculations, but it's good to have that stored with the file just in case you need to go back and look at something. So for example, that could be 253 milligrams. You could also input the reference information if you had anything in the reference crucible. Generally, we will not, but I will sometimes, if I've already measured it, put in the reference crucible mass. Again, it's not used for any calculation, but it's good to have. In the remarks section, you can input any comments about your test, such as particular conditions, particular pre-treatment, or other info you may want to store with the test in perpetuity. In the next tab, you can define the temperature program that you'll conduct the test over, and I'll walk through that in the way that we will typically do it. First thing you may want to turn off is the STC, which stands for Sample Temperature Control, which will control the heating rate via the sample temperature sensor instead of the furnace temperature sensor. You may read our guide if you want to learn a little bit more about why we choose to do that. I'll turn on the purge flows in the instrument. The typical settings I'll use is a flow rate of 50 milliliters per minute for purge 1 and 20 milliliters per minute for protective flow. We can then create the initial conditions. You'll want the start temperature generally to be around room temperature or just slightly above it to get the maximum range in your heat capacity values. So I can go ahead and click initial and add. So now you can see that's been added. Then I'll probably use a isothermal segment. So I'll define the time for that, for example, 20 minutes. And if you click acquisition rate, it'll autofill populate with a pre-chosen value, which is generally fine. Then I'll click add to add that isothermal segment. I can then add a dynamic segment. Let's say I want to go up to 800 degrees Celsius at a heating rate of 10 Kelvin per minute. And then if I click these, you'll see again the acquisition rates will fill in automatically. I'll click add to that. Then I'll use a final isothermal segment. In this case, I'll just use 10 minutes and acquisition rate will fill. I'll click add. And then the last segment you always want to have is the final, which will define an emergency temp that if is exceeded during the test will end the test and shut the instrument down. Generally, the predefined values are fine, but if you're doing a higher heating rate, it may overshoot and you may want to choose something higher, like 830 Celsius in this case. And then I'll click add to add that final segment. So now I've defined the complete temperature program for our test. The next tab will be calibrations, which will generally be used during all tests except if you're actually running the calibration. For the temperature calibration, I can say will be used, and I'll get a dialog box. It'll allow me to select the appropriate calibration. You'll want the calibration to be as recent as possible and to be at the correct heating rate at which you're conducting tests. So in this case, I would choose one with a heating rate of 10 Kelvin a minute. You'll do the same for the heat flow calibration. Click will be used, and then select the same calibration. I can then go to last items, which will prompt me to save my file. So I would give my file a name and click on save. At this point, you can see that all of the tabs on the measurement definition are green, indicating they've been completed successfully. I can then click measure, and that will bring up this adjustment box that will allow me to start the test. You'll want to wait for a second before these buttons become available. You can see they're available now, and then click start to actually begin the test. Here I'll just click exit as the instrument is not quite ready for our new test. Hope this video was helpful and helping you to learn how to use Proteus Measurement and how to create a new measurement definition for your test.